Homogeneous linear differential equations with constant coefficients. Case number 3 for imaginary roots. So if the roots of the auxiliary equations are m1 equals a plus b I and m2 equals a minus b I, then the general solution is y equals c sub 1 times e to the ax plus cosine of bx plus c sub 2 times e to the ax times sine of bx. Example number 1, solve the differential equation d squared minus 4d plus 7 acting on y equals 0. First of all, the auxiliary equation is m squared minus 4m plus 7 equals 0. So looking at the equation, I think we cannot factor this because the only factor for 7 is 1 times 7 and we cannot get negative 4 out of it. We will use the quadratic formula. So we plug in the coefficients. We have negative 4 for b, this one and this. Then we have 1 for m squared for this one, and plus 7 or positive 7 for c. Negative of negative 4 is positive 4, plus and minus square root of negative 4 square is 16, negative 4 times 7 is negative 28, so we have 16 minus 28 all over 2. 16 minus 28 is negative 12, and negative 12 can be factored 4 times 3 times negative 1. So we can extract the square root of 4, that is 2, and the square root of negative 1 is I. So we have 4 plus and minus 2 times the square root of 3 times I all over 2. So divide by 2, we get 2 plus and minus square root of 3 times I. So we have imaginary roots 2 plus square root of 3I and 2 minus square root of 3I. And the general solution is y equals c sub 1 times e to the 2x times cosine of square root of 3 times x plus c sub 2. So this should be c sub 2 times e to the 2x times sine of square root of 3 times x. This should be c sub 2. Example number 2, d to the 4th plus d cubed plus 10 times d squared acting on y equals 0. The auxiliary equation is m to the 4th plus m cubed plus 10m squared. We have a common factor of m squared. So we factor out m squared. So we have m squared times m squared plus 2m plus 10 equals 0. We cannot factor m squared plus 2m plus 10 because the factors of 10 could be 2 times 5. From that, we cannot get plus 2. Also, from 1 times 10, we cannot get the plus 2 in the middle term. So now we are going to use the quadratic formula. So we plug in the coefficients, positive 2 for B and then 1 for A and 10 for C. So we have minus 2 plus and minus the square root of 2 square minus 4 times 1 times 10 all over 2 times 1. Then we have negative 2 plus and minus 2 square is 4. Negative 4 times 1 times 10 is negative 40. So 4 minus 40 is negative 36. And then we can factor negative 36 as 36 times negative 1. So we can extract the square root of 36, which is 6. And the square root of negative 1 is I. And then we divide by 2. We get negative 1 plus and minus 3i. So the roots are 0 and 0 for m squared, and negative 1 plus 3i, and negative 1 minus 3i. So the general solution is y equals c sub 1 plus c sub 2x. So we don't have e here because e will be raised to the power of 0, which is just 1. So you have c1 plus c sub 2x plus c sub 3 times e to the negative x times cosine of 3x plus c sub 3. This should be c sub 4 times e to the x times sine of 3x. Homogeneous linear differential equations with constant coefficient. Example number 3. Solve the differential equation d to the 6th power plus 9d to the 4th plus 24d squared plus 16 acting on y is equal to 0. Okay, so we have here the auxiliary equation m to the 6th plus 9m to the 4th plus 24m squared plus 16. Let m squared equal to n, and that means we now have n cubed plus 9n squared plus 24 times n plus 16 equals 0. And we use the synthetic division to find the roots. Okay, so first we write the coefficients 1, 9, 24, and 16. So obviously we cannot try 1 here because all of the coefficients are positive. So let's try negative 1. So we bring down 1, multiply by negative 1, we get negative 1 plus 9 is plus 8 or positive 8 times negative 1 is negative 8 plus 24 is 16 times negative 1 will give you negative 16, and 16 minus 16 is 0. These are now the coefficients of n squared and n, and the constant term is 16. So we have the factors n plus 1 times n squared plus 8n plus 16. And n squared plus 8n plus 16 can be factored into n plus 4 times n plus 4 equals 0. Okay, so first factor, n plus 1 equals 0. That means n is equal to negative 1. And because n is m squared, so m squared is negative 1, or m is the square root of negative 1, which is equal to plus or minus I, or the imaginary number. Then the next factor, n plus 4 equals 0, or n equals negative 4. And then again, n is m squared, so m squared is equal to negative 4. We find its square root, and we get m equals plus or minus 2i. So the roots are plus and minus I, plus and minus 2i, and another plus and minus 2i. And the general solution is y equals c1 times cosine x plus c2 times sine of x plus c3 cosine of 2x plus c4 sine of 2x. That is for the first plus and minus 2i root. And then for the second plus and minus 2i root, we will now multiply by x. So we have c sub 5 times x times cosine of 2x plus c sub 6 times x times sine of 2x. And we can also combine all the cosine and all the sines. And we have quantity of c3 plus c5x times cosine 2x and plus the quantity of c sub 4 plus c sub 6 times x times sine of 2x.